Welcome back to our next session. Thank you so much. So we're going to discuss about what we call community-based model and why community-based off-grid mini-grid systems are very important for community application, particularly for our indigenous communities. There's so many communities, especially indigenous communities, very much in a remote location. And a lot of the issue about bringing electricity to the community have been faced a lot of challenges, particularly because of the challenging terrain and the remoteness, but also there are a lot of other factors. But in recent years, Tony Boong have developed over 40 different mini-grids throughout Sabah Sarawak, Borneo, and we have been expanding the model to other countries in the region. The reason why we want to promote community-based mini-grid is also looking at how indigenous peoples can practice our self-determined development and practicing our self-determination, because the natural resources that we have at our territories, the rivers and all remain to be managed properly, and there is an opportunity for indigenous communities by harnessing renewable energy, not just to provide electricity for our development, but also there's opportunity for us to connect conservation and energy access. So I'd like to just start by providing a little bit of background. What is going to be discussed here, we'll talk about what is centralized energy generation. We also talk about the issue of distributed energy using transmission and distribution line, and also to look at what is community-based mini-grid in terms of management and so on. But the most important part of community-based mini-grid is actually looking at how revenue generated from the system is being reinvested to maintain and operate the system. So it's not done by utility companies or investors, but it's the community themselves providing a structure and using our traditional customs and traditional law to enforce those so-called community protocol. So in Tony Boong, we have developed different technologies, particularly micro-hydro systems, to enable a lot of this generation being distributed using what we call a mini-grid. So typically, we have what we call a micro-hydro mini-grid. In the previous session, I've explained about what is micro-hydro, the runoff river systems, but I just want to reiterate that a lot of the micro-hydro systems have potential in indigenous communities, particularly those living in the forest and in the mountainous area, because there are potential energy to be harnessed, particularly from kinetic energy from fast-moving rivers. So it's very, suitable for remote areas, specifically on the hilly regions, and we have a very high potential for productive end use of power. Why? Because as long as there is water flowing in the river, we can continuously generate power 24/7 without the need of storage, compared to other forms of renewable, for example, solar or wind, where it's a bit intermittent. So that is the advantage of having micro-hydro systems compared to solar and other forms of energy. So we're also looking at how micro-hydro can be combined into conservation, because a lot of communities have forests, yeah? So we have to protect the forest because that is the storage area for the river. So if we don't have any forest protection, there's a lot of threat that can reduce or affect the water quality of the river that we're going to use to generate power. For those regions that is not hilly or we don't have water resources, the alternative is to look at solar mini-grids. What is the difference between a mini-grid and a solar home system? So a solar mini-grid means the power is generated centrally, and then it is distributed to the different houses and also load areas. So we can also combine solar and hydro to form a hybrid system. So a solar mini-grid can also be combined in other form of renewable, for example, wind, hydro, or biogas or biomass to meet the growing demand of the community. The advantage of this solar mini-grid is it can be deployed anywhere. So we don't need to look at, not necessarily have flowing water or very strong winds. We can put it as long as there's a space where we can put the solar panels and the solar panels are not covered by a forest or building or a hill, so there's no shading. So these are the advantage of solar mini grid. But there is still some issue with regards to having a larger storage space for the battery, because we don't have the sun during a night where we need to use the lights. Yeah, so that is the little bit of disadvantage of solar. But all in all, we can look at the feasibility of these different options to meet the demand, what the community needs. And the most advantage of this is also looking at specifically for very remote coastal communities where we don't have any hydro or biomass resources. We come out to what are the components of community-based mini grids. Okay, of course there are the 5 main components. One of it is, of course, we need to have a renewable energy source. Either it's hydro, it's solar, wind, or biomass. But since we are going to generate it in a centralized system, in a larger volume, then we need to basically transmit the power from where it's generated to the user. So we have some sort of transmission line to connect the place where it's generated to where the load centers are. So once you reach the load centers, then it branches out into what we call distribution lines. So it goes to the houses or the different load centers. And then we have energy management system. So any use needs to be recorded and they must be managed in terms of record and how much tariff is going to be charged on the use of the energy. And the last and not the least is productive end use, because we cannot just rely on just the sales of power to the household level. We also want to make sure that there are anchor tenant or anchor load that is going to take majority of the energy. Because if we don't have, for example, if you don't have a small enterprise, for example, in the kampong, in the village, so the hydropower that is generated, if it's not being used, it's just going to be dissipate acid in the ballast. So it's going to be wasted. Yeah. So to reduce this waste, we're going to promote and setting up of productive end use program. For example, food processing, drying, other use of energy to allow community to create socio-economic spin-off from the available power. But these are very complex because it also brings in another matter of management. So we need to manage money, we need to manage resources, equipment, and so on. But these are some of the things that we really need to consider when we plan to establish our own energy system at our community. So that is why we have to do a lot of community organizing, capacity building, and also partnership with different organizations that has the skills and also equipment to manage the program together. Yeah. So these are some of the examples of project implementation in phases. Yeah. So and then when we want to implement a project, what I call community-based project, the most important part is how do we plan the system? Yeah. How do we plan our project? And the most important part is we need to have free, prior, and informed consent. Yeah. So we have established a very comprehensive guideline on what is free, prior, and informed consent. How do we do the FPIC, and what sort of engagement that needs to happen in the community before we start to implement the project. So it normally starts with introduction and discussion. And it's very important to take note that if you want to do discussion, we encourage that we provide space for the different sector of the community to have a voice. Yeah, I know we have to be culturally sensitive, but sometimes we also have to be mindful that we have to create a proper safe space for different segment of the community to voice the concern and also the ideas. For example, we need to create a special group for the women, for youths, for other, maybe even person with disability, so that they can also be considered and the different ideas that they have. Yeah. So that is why we all start with introduction and the discussion. This allows for co-creation of the program. Secondly, we have to do a lot of studies. We have to know what is the social baseline study. Yeah? So when we do social baseline study, the most important part of the social baseline study is to understand what is the current energy use of the community. Yeah? We need to understand how much they spend on fuel, on different, energy. For example, if they're running diesel generator or petrol generator, how much do they use, how much the cost of fuel per liter, and how much they actually use per night to have access to electricity. These are very important key areas that needs to be noted, because in order for us to understand the impact of our project, we also need to know how much fossil fuel is being displaced by having renewable energy mini grids in the community. So in the social baseline study, we also need to know the community's ability in terms of paying the tariff, because we also don't want to come in and introduce a mini grid that becomes a burden for the community. So we need to understand a little bit of the socioeconomic condition of the community. Only then, when we understand the condition of the community, we have a sense of the community's readiness towards the project and so on, then we go for what we call a feasibility study. Normally, we start with what we call a pre-feasibility study. Yeah? Because we cannot simply just bring all our heavy equipment and start to collect data and do a survey. But we can do a pre-feasibility study by using simpler methods. We're going to explain a little bit more about the methods that's going to be used for feasibility study and what is appropriate for pre-feasibility studies. But once we have this data, we can have enough information to analyze and also to have a preliminary system design. And we can understand that what is the different options that the community can decide, how big the system can be, and how much investment that is required to build that system. Yeah? So once we have some idea on the size of the system, how much does it cost, so it starts the process of fundraising. Okay? So fundraising can be done in many ways. In some countries, it is maybe easier because we have access to grants, overseas development grants, and so on. But in some countries, for example, in Malaysia, where we are considered to be middle-income country, but yet indigenous communities are still very far behind. So we have this issue about how to fundraise. So we have to come up with very innovative way to find money to fund those projects. For example, we engage with the ESG or CSR program of corporate in order for them to support some of these construction projects. We also have established some projects that is done through conservation grants and also the potential of what we call renewable energy credits. Now with distributed renewable energy credits, that is also another potential to be considered. But all in all, the project needs to be funded together with the community, and it should be for the community. Yeah. So we try to avoid what we call a debt-based financing, because we don't want the community to be ended up in debt. So that's why in any community-based model, we try to find partners who are not going to just invest the money, but they also consider to be non-debt-based financing. Yeah. So once we have money, we can start with the tender and procurement processes. I know there's a lot of different technologies and also service provider, technology provider. So it's very important that we have the design ready beforehand so that we can know what sort of specification, what kind of equipment that we want, and how are we going to deploy this project through collaboration with technology and service providers. Yeah. So once the tender and procurements have been signed, then we can start the construction. In the construction process, it's very important that the community also be engaged. Yeah. So that the process of construction, the community knows the different components, how it is being built, where should be the different structure is being placed, and so on. Because we need to make sure that everybody is consulted. We have found a lot of experience before this, that if we don't know or we don't consult the community beforehand, we might have problem, especially when it comes to land ownership. is going to be very, very messy. So it's going to be very, important that community is consulted, and especially those who are willing or interested to join, they should be provided the room to join the construction team. Yeah. And once the system is been tested, implemented, comes the testing and commissioning. It's very important to do the TNC in the presence of community representative, the NGOs or the project developer, and also we have the technology providers. Because sometimes there's a lot of cases where projects have not been properly commissioned, and when during the commissioning there is some technical issues that have been hidden from the community, and at the end of the day it created a big problem, and they have resulted in the demise of the project. Yeah. So these are something that is very important, that community needs to be involved in all the process. And for us, in the community-based model, training and capacity building for the community is very, very important. So we need to make sure that the community have, selected minimum 5% in the community. Doesn't care if it's women, men, it should be given equal opportunity to join, to become and train as the community operator. Yeah, the operator is where we're going to train them on how to do the operation and maintenance. And also, the most important part is to make sure that all the systems are safely operated. Safety issues is paramount in this factor. Yeah, so that's why we need to make sure that they understand the different components, they understand the different names of the parts, and they are trained on how to do the reporting and monitoring and reporting, in the monitoring system. And last process is handing over, and we have to do some monitoring. Handing over is basically just a simple, ceremony to hand over the responsibility from the construction crew to the management crew. Yeah. And after that, there should be at least 2 years of monitoring, further hand-holding, particularly in the management of the system, and also taking the record, and also looking at how you develop the productive end use of energy in the community. So this is some of the good practices and recommendations that we have established over the years when developing community-based project. Okay, let's dive a little bit more on feasibility study. So on the microhydro side, I think the team have shown how the different equipment and the methodology used to measure the head and so on. But what I'm saying here is like the most important part of the feasibility study is the data needs to be correct. Yeah, the problem with the feasibility study data is we don't time it properly and we don't do it properly when it needs to be. For example, when we are trying to do flow measurement and the river is being slightly flooded and we don't take note or we don't declare the condition of the river at that time. Yeah. So what we have is actually a very bad data. So when we design our system, it's designed based on like very, very superficial high flow, and in the end we oversize the turbine, and when we commission it, it cannot run the full 365 days of the year because it can only run during that particular wet season. So that's why for microhydro, timing is very important. So you try to time the feasibility study, especially for hydro, during the driest period of the year. Yeah, so that you can design a turbine based on the lowest flow, and we can make sure that even at the lowest flow, the system still can run. So the idea is we want to make sure that the system can run at least the full year, or we want to reduce the disruption due to dry season as minimum as possible. The second one is the equipment that we are using. Yeah, it's very important to make sure that our equipment are properly calibrated. Yeah, properly calibrated. I have seen that some of those data, even though it look very promising, but suddenly when we key in, it's like it doesn't make sense. Yeah, because the calibration is really off. So we need to make sure that our equipment is also well taken care and also calibrated from time to time. We don't want the data that we got is actually very far off from what is the reality. Yeah. So that's why we need to make sure that our calibration and the methods. And the third one is like practice. Yeah. Practice makes perfect. Of course, a lot of the time, especially when you're using the flow measurement, it'll take time for us to practice this. Yeah, and the data that we collect actually becomes better with more practice. The accuracy increase with more practice. So hopefully these 3 tips that I presented for feasibility study can be implemented by our NGOs or whoever is going to develop the project. And I think comparing it with the baseline data is also important, because sometimes we have a lot of potential, but when we look at the community or the side, they are not ready, because I think we still need to do other intervention, for example, economic empowerment and so on, because I think poverty is a very serious issue, because if it's too much, the poverty is very high, then the ability to pay is very low. So we don't want this system to also burden the community because their inability to pay the energy tariff. All right. So once we have done the feasibility study, the next step is to look at the design of the system. So I just want to remind that the equation for microhydro is this. Yeah? Power potential equals head times Q, which is the flow, times 9.81, which is the gravity. Okay, so this data needs to be acquired on the site properly and as accurate as possible, because if we don't have these accurate numbers, we also have inaccurate sizing of the system, and the worst part is we have oversized or over-designed the system, and it cannot run properly during the operations after completion of the project. So that's why data analysis is important. We must make sure that all the data that we collected are in line. And then once we know the potential, the second step is to look at turbine selection. Because the head is actually different in terms of different types of turbine. So the higher the head, meaning to say we need to select, for example, impulse turbine. Yeah? And the lower the head, we're going to use what they call a reaction turbine, low head system. But when the flow is not enough, what happens? Yeah? When there's not enough flow, we need to start considering other options. For example, solar, or wind, or other form of renewable, for example, biomass. Or we can do what they call a hybrid system. Yeah? So the turbine selection and sizing is important. The next part is, once we have that, then we look at the structure, civil structure design, we look at transmission, and we need to know what are the output of this analysis, which is bill of quantity. What is a bill of quantity? Bill of quantity is actually the list of equipment and material that you need to do the construction, and the volume of the material and also equipment that is needed to complete the project. So with this, the known price, we can basically establish the cost of building the systems. And the last but not least, technical design drawings, because we need to have this reference during the construction. We have to have drawing as a reference for the community to construct the civil and other technical stuff. But also, sometimes we need to submit these drawings, technical design, to the authority to ensure that they can also certify this equipment and setup. So these are just some of the examples of the different civil works. So you can see there's pipes, there's a lot of excavation, there's a lot of concreting, So it actually also requires some sort of skills. Yeah, we need skills. So we need to make sure that when we do the construction, we have the necessary skills on site. For example, if we are doing the construction for civil works, we want to make sure that we have someone who knows or has the skills to do concrete works. Yeah? When we do piping, we know someone who can do the welding, how to operate the welding machine, and so on. Yeah? So we need to make sure that we have the the skill sets, and we refer those construction based on the drawings that we have been produced. The next is the mechanical works, civil mechanical. Mechanical is actually anything that moves, that spins, is actually called mechanical. That includes the turbine and the generator. We also refer this as electromechanical equipment because it converts the mechanical torque, mechanical power into electrical power. So we are looking at the different type of turbine, what the different type of generator, what kind of mechanical component, and also how this system is being installed in the powerhouse and so on. So this is just for the micro hydro. For mechanical works under solar PV, yes, there is still mechanical works, even though there is no moving parts in solar power, but we are still consider steel structures, the roof mounting, the solar mounting, battery mounting. These are all mechanical components that needs to be designed properly. And then we come into the electrical works. So in the electrical work, we have three types of electrical work. One is the transmission line. The transmission line is where we transmit the energy that was generated by in the powerhouse, the solar farm, to the community. Because sometimes the location of the generation is not really near to the community, because for the case of solar power, you might need to have an open field. So it might be not really very near to the village. Or for the case of micro hydro, the river is not too close to the community. So you have to have a transmission line. Normally, a transmission line consists of cables and also electrical poles in terms of single-phase or three-phase transmission. The second part is controller. Any electrical system have control system. It controls the power that is generated, the control of voltage, the frequency, and so on. So the control system is a very important component to ensure that the quality of the power that comes into our house is actually as same or even as same as par as the national grid standards. So these are important. And the third part is the house domestic wiring. So we cannot compromise with safety. That's why we have to follow a certain guideline on how electrical wiring is done. And in every household, there must be what we call a distribution box, there must be grounding, and there must be insulation. And making sure that all the no exposed live leads that can lead to electrocution, can lead to fire due to short circuit. So these are important components that needs to be observed by all parties, and specifically for our developers in the community. We have maintenance. Maintenance is very important because if there's no maintenance, the system doesn't last long. That's why we need to have what we call a PPM, periodic preventive maintenance. And this PPM in a form of a schedule. So for micro hydro, the most important part that needs to be maintained is the powerhouse, which house the turbine and the generator. It needs to be clean. Turbine has a moving part, especially the bearing. It needs to be lubricated based on the SOP that normally already determined by the manufacturer. And also making sure the controller is always free from dust and also not being exposed to the elements. Or the most important part is to ensure that no gecko or rat can go in there and destroy the controller, because we live in humid and tropic countries, and especially we are in the jungle. We have a lot of rats, other bugs, and also gecko that normally goes into the controller and can cause short circuit. These are important. The other component that needs to be maintained regularly for micro hydro is the intake and also the forebay. Because the intake is where water comes into the system. And as we know, if there's rain or there's flood, there's a lot of debris. And this debris needs to be cleaned from the trash rack regularly. And in the forebay, there will be silt. The main function for the forebay is to to make sure that there's no silt, any heavy debris comes into the pipe, the penstock pipe, and goes into the turbine. Yeah, so you want to make sure everything is settled. So we need to clean that regularly. Yeah, especially after heavy rain, flood. Yeah, we need to make sure that this is done periodically. And the turbine, pipe, the transmission system needs to be checked. Also, we have to make sure that the local operators are also trained and they follow the schedule. And last but not the least, to report the work that have been done by the operator. They need to record any work that they have done in the powerhouse or the intake for bay, so that the management knows how much they need to pay the operators monthly. Okay, these are something. So it's the same thing for solar. They need to clean the solar panels regularly, because if you don't clean the solar panels, dust build up and it will slowly starts to build and grow algae. And the moment the algae grows in the panels, the power generated by the solar panels reduce, and it will affect the system. Yeah, so we need to make sure that the system are clean regularly. Okay. Yeah, and operators training. These are also important. I said earlier that we need at least 5. When we start the project, we need to have at least 5. Why? Because sometimes not everyone can be in the village at the same time, right? So we have to take a turn to take care. But at the same time, the training needs to be done from time to time, maybe once a year or once in 2 years, because maybe some of the operators have already retired or they move on to somewhere else. So new operators come in. So the new operator needs to be trained. Also, there is technology advancement. For example, in Tonibung, the controller that we have for the micro hydro have changed over time. Yeah, we have increased the capability of the system, and all operator needs to know how the new program or the new system is being managed through the cloud system or the smart grid and so on. This refresher course needs to happen from time to time, and this needs to be communicated from the community. The community energy management committee needs to be informed, needs to inform the NGOs, Tonibung, or the Right Energy Partnership, or whoever partners that you have, to conduct this refresher course specifically for those who are just joining as the new operator. Okay, and then only operators that have completed this training course should be allowed to operate the machine. Yeah, even doing maintenance and so on. Because these are very important, because we need to have a certain degree of competency, especially on the community level, to ensure that there is safety and also the SOP followed thoroughly, so to avoid any breakdown and so on. So these are something we have to emphasize in our program. Yeah, so I just want to share some of those different names just quickly. What are the different components in civil structure? So in intake, normally what we see is we have concrete structures, and we have small weir. A weir is actually a small structure that block the water so that it can be channeled into the intake mouth. Yeah, and in the intake we have sluice gate that controls the flow, how much water you need to divert coming into the system. So these are the intake. Yeah, so the function is to actually mitigate flood and make sure that this is also the first stage filter, because it will filter all the big debris, the logs, the leaves and so on. Only the sand and maybe small debris comes in through the intake. After the intake, then we have these are just the different examples of the intake that we have constructed before. Some of it in Kampung Tiku, Long Lamai, and in Sarawak, and also looking at where the system, the sluice gate is being placed, and you can see that the screen that opens up is where the water comes in to the system. Yeah, so we also try to use available material on site. So instead of bringing all the concrete from outside, we try to use the sand and gravel and whatever material that we have on the river to make this construction less expensive and laborious. Yeah, these are another example of how the system is being operated This is in Kampung Long Lamai. You can see the river and how the system only takes what the turbine needs, and the rest of the water actually still can flow to the river to minimize the impact to the ecosystem. The next is the forebay. So the function of the forebay is for sedimentation. Yeah. So when the water from the intake comes in, it goes to this sloping area and it reduces the velocity of the water. So it opens up to a larger area, and slowly it will reduce the velocity of the water, less turbulence. We also make sure that there's no bubbles coming into the turbine, to the pipe, and disrupt the flow of the water in the turbine. And the most important part is like we want the sand and also mud to settle down on the basin and doesn't go through the pipe. Forebay also have what they call a slanted silting basin, and also what we call trash rack. Yeah, it's a second stage filter, but the main function is to making sure there's no debris coming into the pipe. Then we can see the different concrete structure that was built. This is in Kampung Tiku, and that one in Kampung Long Lamai, and you can see that it's very near to the existing river. And then the spillover of the water, once it reaches the desired level, it actually goes back to the river. Okay, so after it goes into the forebay, it goes into the penstock pipe. So penstock pipe is almost similar to what we call a transmission line. But instead of transmitting electricity, it's transmitting the water and then the kinetic energy of water. So if the water will flow very fast downhill, and it goes in all the way to the turbine. Yeah, and in some parts where the pipe is in a slightly bend, we have to make sure that it is properly anchored using what they call an anchor block, a truss block, because there will be inertia in the pipe, and we have to make sure that the pipe doesn't move. Yeah, so we have to build those truss blocks, concrete anchor blocks, and so on. So we want to make sure that it is solid and doesn't move, because any movement over time will create cracks in the pipe and it will develop leaks. Yeah, so penstock pipe is important. Penstock pipe can be used based on the steel, plastic, which is PVC or HDPE, or we can also use what we call composite pipe using concrete reinforced fiberglass. Yeah, we can also use that. So it all depends on the sizing and also the availability of those material for our project. And then we come to the powerhouse. The powerhouse is where the electromechanical is going to be housed, the turbine and then the controller. And it doesn't need to be big as long as it's safe. It's not exposed to the elements, and nobody can go in there without authorization. Yeah, it has to be able to be locked. And the turbine, where the community needs to do maintenance, everything, all your tools have to be stored at the powerhouse. Okay, so the electromechanical power equipment, it consists of the turbine, the dynamo, and the controller. These are the three components, and actually it's one of the most expensive part of the system for microhydro. But in solar power or other form of renewable energy, it can also be the gasifier or generator, battery and controller. So this electromechanical equipment that needs to be secured, because these are the biggest investment that you need to make in any system. So the controller that we have been using is called ELC, Electronic Load Controller, and it basically provides a level of control on the frequency and voltage of the system. Yeah, so it needs to be maintained, but a lot of it now, because of the advancement of technology, operator doesn't need to do a lot because it's all pre-programmed and it's been automated by a set of codes that is already uploaded in the microcontroller. So operator only needs to maintain the water flow and also the mechanical side of the turbine. Okay, and then we have the transmission line. A three-phase transmission line means there is 3 lines that needs to be maintained. And from the transmission line, then it will be separated into a single phase going to the houses and so on. So these are some of the things that have to be built and also maintained regularly because they will be overgrown. Yeah, once the transmission line is put there, especially there is no small trees or brush that going to grow in the transmission line, then that area needs to be cleaned up from time to time because we don't want trees to fall and topple the transmission line and cut the power supply to the community. So this is something that the community and operator needs to do quite regularly. And to ensure safety, all of the transmission line is equipped with what we call an insulator. Yeah, and this insulator insulates electricity that flows to the cable or the conductor from going into the ground and can electrocute people that in the surrounding. So make sure that what we call the porcelain of the insulator is properly maintained, there's no breakage, and so on. I think in the last slide, we have covered quite a lot in terms of the concept of community-based, community-owned systems to the extent of explaining how the community can do the construction. And lastly, I was explaining about the components that needs to be maintained and operated by the Community Energy Committee. So I end here. So if there's any question, please ask us. We can always be here to answer your question. But if you need further explanation, we also can refer to the manual that we have produced. So thank you very much and see you in the next lesson. Thank you.